Now we will learn how to perform hypothesis tests that compare two samples. Some examples of applications that call for two-sample tests are determining whether statistically significant differences exist between the same characteristic of different groups, for example between males and females, comparing the performance of different versions of products, checking what factors influence a certain parameter, such as geographical location. First, we consider hypothesis tests that compare the means of two samples. This calls for a new sampling distribution, the sampling distribution for the difference of two means, which consists of probabilities of observing various gaps between sample means of characteristics of two different populations. To work with this sampling distribution, we need a standard deviation, which is the standard error of a difference. Note that the samples from the two populations do not have to be the same size, and that the standard deviations of both populations are needed to compute this standard error. When the sample sizes are sufficiently large, the sample distribution of a difference follows a normal distribution, just as in the case of a single mean. Then we have the same old test statistic, sample value, which in this case is the difference of sample means, minus the hypothesis value, which is 0 because we're comparing the difference of the means to 0 in some way, divided by the standard error. For now, we assume that the two samples are independent of one another. We will consider the case of dependent samples later. Let's consider an example in which two types of tires are compared. We sample the lifetimes of the two types of tires and take their sample means. Then we also take into account the population standard deviation for the two types. The hypothesis test that we will perform will test whether the mean lifetimes of these two types of tires are equal. Since we are testing for equality, we use these hypotheses for a two-tail test and choose alpha equals 0.05. From all of our given information, we can compute the standard error of a difference. Then we compute our test statistic. The difference of means is being compared to 0. That is, our null hypothesis can be viewed as mu1 minus mu2 equals 0. So with that in mind, our test statistic is the same as always. Sample value minus hypothesis value, which is 0, divided by the standard error. Because this is a two-tail test, we need to compare our test statistic against z alpha over 2. The absolute value of our test statistic is greater than z alpha over 2. So that means we must reject the null hypothesis and conclude that the two types of tires have different lifetimes. That is, the difference between their sample means is statistically significant. As before, we can compute a p-value for this test, which for a two-tail test is twice the probability that capital Z is greater than the absolute value of a test statistic. As the p-value is 0.035, we can conclude that H0 would be rejected at any significance level above 3.5%. So far, we've assumed that the population standard deviations are known, but what if they are not? As before, we use the student's t-distribution, and we must use the sample standard deviations whenever they are needed in the formula for the standard error of a difference. In addition, if the sample sizes are small, then we have to assume that the populations are normally distributed, to ensure that the sampling distribution of a difference is normally distributed as well. We will still assume for now that the samples are independent. When that is the case, a hypothesis test of this kind is referred to as an unpaired t-test. We consider two cases. Either the unknown standard deviations are assumed to be equal or unequal. If we believe that the populations have probability distributions that are very similar, just with potentially different means, we can assume that the standard deviations are equal, in which case we can compute this pooled estimate of a standard deviation, which arises from considering both populations together. Note that when we compute the standard deviation of a single sample, we divide by n-1, where n is the sample size, and n-1 is the number of degrees of freedom for the sample. With two samples, we deduct 2 instead of 1 from the aggregate sample size, because 2 degrees of freedom are taken away by the two means. Now we can use our pooled estimate of a standard deviation to compute the standard error of a difference. Then we have our usual test statistic. We define a new variable d to be x1 minus x2. So d bar is the difference of sample means, and d naught is the value that we are comparing the difference of means against in our null hypothesis, which is usually 0. As an example, we will compare customer satisfaction scores for two stores in the same chain. The samples are small, so we must assume that the populations of scores are normally distributed. We do not know the standard deviations, but we will assume that they are equal. Our hypothesis test will determine whether these scores are statistically equal. We state our hypotheses. The null hypothesis is that the mean scores are equal, so our alternative hypothesis is that they are not. We choose a significance level of 0.1, and then gather all of the pertinent information about our samples: the sample sizes, the sample means, and the sample standard deviations. We are assuming the population variances are equal, so we compute our pooled estimate of a standard deviation, and from there, the standard error of a difference. Now we compute our test statistic. In our null hypothesis, we are equating the difference of means to 0. So 0 is our hypothesis value d sub 0. And the difference of sample means is our sample value d. As usual, we divide by the standard error to get our test statistic. Then we compare the test statistic to t alpha over 2, n1 plus n2 minus 2, because this is a two-tailed test, and this is the number of degrees of freedom for two samples. We find that the absolute value of our test statistic is greater than our threshold t-value, so we reject h0 and conclude that the means are not equal. One store is getting higher customer satisfaction scores than the other.